Assalamu alaikum, dear viewers. Welcome to our YouTube channel Design Experts. In this topic today we will discussing about the single beam load assignments, and we selected user default settings which is already saved setting such as live load, seismic loads and wind loads. We selected all the dimension as assumed for this beam as will stories for this beam. So it is a simple beam, simply supported beam with two columns. We will apply point load on two different spans and one distributed load. So the columns is already as a user default setting. From the user default setting we have already saved, so here we select column C1 for this beam, and the beam will be selected as a B2. So we will study the complete diagram of the beam, reports, shear and flexure, and also we'll discuss about how to modify the dimensions and re-verify it that if the beam loaded and they reduce the sizes of the beam, so what will happen if the due to the high intensity of load and non-economical beam is used, so what will be the reactions of the column and what will be base response. We will also see the diagrams of shear force and bending moments as will base response of the load. So now select the point load from the end to 2.5 from the end to this shear end point, and the other will be from for the last here it will be 3 meter kilonewton. So okay, we cannot assign the load to the center point because the maximum bending moment it have not allow to assign the point load into mid span of the beam. So that point load has been assigned, you see here. Now we assign distributed load. So the distribute uniform distributed, it is distributed load. We select from here to here, it will be distributed on the area of the beam. We select it 10 kilonewton per meter. Okay, so you see that 10 kilonewton distributed load has been assigned to this beam. So now we will check the load pattern, that live load, dead load, earthquake load, live load and wind load is already assigned. So now we run analysis. Before the run analysis we save it. So now the analysis is running. Wait till to the once the analysis is completed. Okay, so now check so this is the deformed shape of the beam. So now we are going to check the shear. The shear diagram is here. That it shows that the beam is economical and of the 2 point loads and one distributed load, and shear 3 is also economical because it not shows here, and bending moment 3 is shows that the beam is economical and the column is also economical for this load. So now we check the design check. So now we will see that the design check is completed. Now we verify all the members. So all the concrete members has passed the design check. So right click on the column, so you will see the detail here, and right click on beam detail, go to detail, and all the detail is given here, such as section properties, material properties, shear force and reinforcement detail, and flexure shear, it is the beam elements detail, flexure details, and etc. So shear loads, you can see here beam elements detail, shear details, section properties, and shear rebar design. So now here is the shear reinforcement per major shear and area of the steel bars using here. So now we will check the diagram of the beam. So it is the diagram of the beam is 200 by 600 mm. So the 4 steel bar is already used in this beam. The length, our total length is 7 meter, and section is 200 millimeter by 600 millimeter. So this is the distance to the bottom rebar centroid. So concrete compressor strength is 27.58 MPa, and concrete modulus longitudinal rebar yielding is 413.69 MPa. This is the beam. So this is the moment diagram, which is in center point it is 0, 90, and positive is 94.87. Here is the shear is shown as, so this is the shear 15.5 in the midspan, and it is the economical section of the beam. Okay, overrides means that we can change the dimension from here also. So we want to change from here, but the beam is economical, so it will be not change. If the beam shows that if fail the design check, so it you can change from this point. So now verify all the concrete member is past the design check. So we change the check 200 by 300 is also the beam is economical for this design, for this load assignments. So 600 by 200 it never be changed, as already I told you that, because that's why, because we will go to the delete the analysis, and click here to delete the analysis, yes, and okay, we deleted the analysis. So you know the lock is opened. So now go to material, section properties, and from here you click on the define section properties, click rectangular B2. Now modify and show the property. From here we will change it 300 depth and 200 will be the width. If from here if you change it's okay, if not no problem, but bottom will be must, you have to change. So now run the analysis because we reduce the size of the beam. So now we will check the failure. If the check fails the beam, then you will see. So now it shows in undefined shape that the beam is economical also for this load, but the column is shows failed because the red line shows the failed columns. Now we see, check the shear moment. So the moment shows that the column is failed. The beam is past the design check. It is economical, very economical, because the bending moment at the midspan is maximum, and shear also and maximum, and the joints between the column and loads. So the column is shown like fail. Verify and check the concrete. First we run the design, the check. Go to 3D. Now rotate the beam and check this design check. Two concrete member is failed, so it means that the column is failed. So you see that the two members is failed. This is the load 6.9 meter. From here it is seems like 0, 0. It is not shows the value. Okay, first we run the design check. If you not run the design check, it will show you the, it will not show you the properties. From here you see that the point load is mixing. Now run the check the model. Now we will see that detail is here given for the beam. Right click on the beam and the detail is before like. So you will see the diagram also here. You can, from here you can change the beam sizes. If your beam became fail, you can change from here. Now go to the diagram. So the diagram has been changed from 200 to 300. So the bending moment diagram is okay. It shows that it is okay, and the analysis request is the area of steel request. Here you we will provide a shear bars at the near the supports. So the beam will be became up became pass, because here you know that the shear, we will have to increase the shear bars near the supports. So now click here, you will see that the so this one is the surface section of C1 column ACI 318-14 section 0.7. So here you see that the column from this side is shown like fail, because you have to increase the, if you increase the area of the steels, so the member, the structure member column will be become pass. So here you see the value when you click here. So this is the P into kilonewton and the moment in kilonewton per meter. So due to the moment, the failure is due to the point load. The column is seems like a fail here. So moment 3 one side, if you increase the shear bar, maybe the column will be become pass, but here it seems like it is fail. So now we check the base response. So we see that here it is 444. It means that the load is not transferred properly, so the column soon seems like fail because the base response is not good. These two columns seems fail. So now overwrite on this here and change the size of the column. Okay, 200 to 500. So now we'll see that the column has been changed. Now we select another column as well. Here right click in here and overwrite, and okay, and okay. Now see the another one column also, same, right click here and overwrite here, select the C2 column, okay, and okay. So now see, now check the design check is completed. Now verify the member are passed. Verify the members, all the concrete frames selected pass the design. So the design check has been passed. Now the column is been that the size of the column has changed. So now see the moment of 33. Here you see that now the design is okay and the beam as well the column is okay. So that dear viewers, that was the way to check your beam, your columns. If your column fail, how to pass, and if the beam is fails, how to pass. So it is the diagram of the beam bending moment. So it is mixing at the midpoint. So go to undeformed shape, click right click here and go to detail. This is the detail. So this is the diagram of the beam. You can also see the diagram of the column as well. So my dear, if you like this video, so please subscribe our channel and click on the bell icon.